Okay, folks, we're going to start the second part of our morning session with Emmanuel Cecchet.
Wait for the end of the talk to see if that's really worth it. Yeah, so I'm Emmanuel. I work at UMass. I've been working there for the past 15 years on different cloud-related projects. So the thing I'm going to talk about today is CloudLab on ESI. So first, a few words. ESI, by now, if you pay any attention this morning, you should have an idea of what it is. If you don't, you can ask those guys who presented before me. And so we have part of the resources that we use in the cloud that are managed by ESI, that's Elastic Secure Infrastructure. And I'm working on the Open Cloud Testbed, OCT, where they use CloudLab as a management system. So CloudLab has kind of the main goals as ESI on managing the hardware infrastructure. It's a much older project that started 20-something years ago with Emulab and evolved over the years. So it's a relatively large code base with a lot of legacy stuff to support all systems. And it has been developed by the University of Utah. So actually the CloudLab site that we have here is a satellite site of the CloudLab deployment that is kind of centralized in Utah. So what are the motivations behind CloudLab on ESI or having CloudLab and ESI work together? We have this great data center in Holyoke, Mass, the MGHPCC, where we have a lot of hardware that is deployed. On one side, we have NERC that have their own racks, and they are using ESI to manage the hardware. And we have OCT that also have its own racks and runs on CloudLab. And actually, Oran brought that up one day and said, well, I'd like to be able to share some of those resources, take the NERC rack, make them available to the CloudLab users, and when they don't need those machines anymore, we can put them back in NERC and use them on ESI. And the problem is that those systems originally are designed to have exclusive access to the hardware and manage their own hardware, their own switches, their own nodes, and they are not made to share racks between each other. So the idea of this project is trying to see, can we just put hardware in the data center and make it available to everybody and just move it around? So for this to happen, we have basically two problems to solve. One is who is owning the hardware at any given time, and how can I lease the hardware to some other user and then reclaim it back? So we're going to see the lease mechanism in ESI that are actually great for that. And once we have actually given ownership or the rights to another lessee to use the hardware, how do we make sure the two systems can cohabit in racks or sharing some of the hardware and be able to run together on that hardware? So here on the slide, you can see we have NERC that is running on ESI. We have OCT running on CloudLab. And so the idea is to deploy ESI everywhere and have CloudLab run on top of ESI. So now we just have a single management layer for all the hardware, which is going to be ESI. And we're going to try to modify CloudLab to make it run on top of ESI so that we delegate all the hardware management function to ESI. And that has a number of challenges, but in the long run, that's also solves a lot of problem when you have to onboard hardware, add new hardware to systems. You don't have to do the work twice of finding drivers in each environment to make the hardware work and reconfigure everything to the databases, etc. So ESI has a great mechanism of leases and offers. So let's say NERC owns hardware. I have some comments there you can see on the top right. NERC can decide to create offers to offer some of the nodes to CloudLab. And there's this ESI offer create command, and you can say, I want to offer my nodes to CloudLab for this time period. And each node gets an offer associated to it. And on the other side, CloudLab can claim those offers and get ownership of those nodes for the specific period of time. And while the CloudLab has claimed ownership of the nodes, it will retain exclusive ownership of the node until the lease expires, meaning that no other user will be able to use those nodes. Here we have exclusive in quotes because actually the ESI user can do still operations when the nodes are leased, but in the if you think about it, it's like basically we give the node to CloudLab, CloudLab will be the exclusive user of that node until the lease expires. So what I'm going to talk about now is the prototype implementation we have. It has nothing to do with the current production system. We have NERC running ESI with their own machine. We have a OCT deployment with production nodes. Here we created a small test bed with 16 nodes that is accessed both by CloudLab and both ESI, and we have a development environment for each. And so the idea is to say, we have this mini environment, we are going to take those 16 nodes from ESI, share them to CloudLab, have CloudLab use them, and at the end, give them back. So here we have 16 nodes that belong to the CloudLab ESI demo user, and if I do the node list command in the OpenStack console, I see my 16 nodes available, and the one at the bottom here is what the view that you have on CloudLab. CloudLab doesn't see any nodes. You do a bare metal node list. You don't have any hardware available because you haven't claimed any offer yet. So the offer list, I can see all the offers that are available for those nodes. So the next step is for CloudLab to claim those nodes. So there's an ESI offer claim command where you can claim the nodes, and once the nodes are claimed and you try to do a node list, you will see that actually leases have been created. So that's the ESI view of things after the nodes have been claimed. There is a lease that is created to each offer that have been claimed, and we can see the name of the lessee here. It's CloudLab who has claimed those nodes. So now if I am doing my OpenStack bare metal node list on the CloudLab side, I see my nodes that have been offered to me, and I can do whatever operations I want, pixie boot them, turn them on and off, etc. I own those nodes. I can deploy whatever I want on them. So now that CloudLab has bare metal hardware, CloudLab has to make those nodes available to its users. And so there's a process, whether you are in ESI or in CloudLab, where once you have hardware, you go through an inspection process, make sure the nodes are actually up and running so that you don't offer nodes that are not working to the users. And so in CloudLab, this is called the OS reload operation. And so you reload all the OSs. It's going to try to pixie boot system and make sure everything comes up online. And once all the nodes are have been gone through that process, when you go in the CloudLab web interface to reserve nodes, so here you can see that the CloudLab GUI, you can go in the and say, I want in Massachusetts to reserve some of the hardware. The hardware we're using are those 16 FC430 nodes, and I can put a reservation on them and claim those nodes and then work with them. So once the, let's say those nodes were given to us for three months or 6 months period, at the end, when we have to give the nodes back, the only thing that is really needed from the CloudLab side is to delete the leases. So the leases can expire if you had put a fixed end date when the lease expires, they are automatically returned. If you want to return them early, you can just do an ESI lease delete. And then the nodes are, now you can see the offer. If the offer hasn't expired, it can still show up. If the offer actually also has an end date that has expired, all the leases get cleaned up and the offers disappear. Here, if the offer is still open, that means CloudLab could try to reclaim those nodes again and lease them for another period of time. But once the leases have been deleted, you can see the bare metal node list returns an empty list because the nodes have been returned. So what did we learn so far doing this little experiment on plugging CloudLab on top of ESI? So the first thing is about the hardware. We got a lot of donations of hardware for the different clouds we are running at MGHPCC, and every time we get a different kind of hardware, there are headaches on finding the right drivers, finding the right configuration and the right setup to make those server works. And so when you have multiple managing environments, you need to do the work for each of them. So you have to figure out a way to make those nodes work in ESI. You have to find a way to make those works node in CloudLab. CloudLab is even more challenging because it's a very old software stack. They are still using FreeBSD, which has very limited drivers for some of the more modern hardware. Like even the FC430s we are using in this demo, CloudLab is not designed to boot anything on to use 10 gig on the management networks. It tried to force the links to be only 1 gig. We're kind of lucky for this experiment that the hardware was so new that it wasn't in the exception list of FreeBSD, and they were like, we don't even know what it is, so we're going to try to boot it, and that kind of worked because it wasn't hardware they couldn't manage properly. But there's always challenges in trying to get onboard machines on those different environments. It's still a very, very manual process. So the approach we have right now of running CloudLab on top of ESI, CloudLab originally was just developed in Utah to manage their data centers, and then when they started to add more data centers, they have the option of you can book resources like 2 servers in Utah, 2 servers in Wisconsin, 2 servers in Massachusetts, stitch them together, create your own VLANs to connect those resources together, which means they have to have control on all the switches on the network path to set the VLANs and stuff. Here we are delegating the VLAN management to ESI, which means we cannot, ESI cannot control the rest of the CloudLab network. So the approach we took for the network design only allows us to share resources within the Holyoke data center at MGHPCC, but we cannot stitch those resources with remote sites on CloudLab, which is not a big issue, but it's a current limitation of the approach. The great thing, though, is that now if we can make the entire network stack of CloudLab run on top of ESI, we don't have to deal with populating the CloudLab database with all the MAC addresses and all the stuff that is needed to access the bare metal hardware. We can just give the IDs of ESI and let ESI manage all the details of accessing the actual hardware at the bottom. So it's still work in progress, but we have a good testing environment now to complete that implementation. Part also of dealing with old software and bunch of scripts and stuff is that this is academic software that has no testing environment, no test suites, nothing extremely hard to debug. So progress is always slow. It kind of. I'm sorry. Yeah, I'm talking about CloudLab. Yeah, no, I would love, and that's the software that is developed in Utah. The great thing with ESI is that we have all the Red Hat folks that are here and being very active on the development, and much newer software with a much newer design. When you are dealing with legacy software, is always much harder. So one thing I'm hoping now is that, especially with all the interfaces that ESI is exposing to us, we'll be able to automate the resource discovery. I can pull from ESI the list of nodes that are available, just put that information in CloudLab and say, those are ESI nodes, you don't need to know any other details, ESI will manage that for us, and simplify a lot of the onboarding process and management process. One of the paths we could go that's still would be a very long-term goal would really have to have a network switch driver for ESI in CloudLab. There's still some more work to be done on the interfaces for that to happen, because CloudLab really expects to see a switch, port numbers, VLAN assigned to ports, etc., where in ESI, you are more manipulating networks, attaching a node to a network. Yeah, the VLAN is attached to that network, and you can try to network together, but it's not really a vision of a switch with ports like you would have in a traditional network. So I think the goal of this is so that we can have people donating hardware. They don't have to think as like, oh, should I give hardware to NERC or to OCT? It's like whatever hardware you are gonna you are gonna contribute to the platform, we can easily move it and make users have the best use of them between the different platforms, and we can dynamically put them to CloudLab users, NERC users, OCT users, Fabric users, or any other framework that's gonna give access to those resources. So. That has been definitely an interesting experiment. It's still ongoing, and we're hoping that hopefully by the end of, after the summer, we'll have a completely running platform and be able to move the nodes between the two platforms. Thank you. Any questions?
First of all, thank you for your talk. So I have a quick question. In your demo, you mentioned like ESI offers the bare metal resources and CloudLab actually claims those resources. So is it true otherwise as well, so that we know like CloudLab is now working on top of ESI, but whenever ESI wants some resources, it can just ask CloudLab and claims those resources from CloudLab. So is that possible? And based on that, can ESI provide those resources or lease those?
There are two ways of doing this. The ugly way is just to say the hardware is down, and then it's flagged in the database and it's not available to users. But a cleaner way is to say we have an ESI user that can have a priority in the scheduling mechanism, and say we are blocking all those nodes for the ESI users for that period of time. There's still a limitation that CloudLab expects to have exclusive access to the switch. So it's easy to share an entire rack with a switch at the top. When you start to want to share just half of a rack with someone else, there's still only one switch managing all the machines in that rack at the bottom. And sharing the admin of a switch for just few ports is not something that is easily doable, especially in CloudLab. It's much more flexible to do that with ESI.
So this is great. If I ever would have realized how hard it would be to integrate this, I don't know if I would have promised it that a couple of years ago, but it is. I just want to kind of set the stage for the three talks and what you did here. I mean, so when we were looking at CloudLab back when, it was, we as systems researchers, would use this platform. It's incredible. It's been incredibly valuable for us. But, now when you have a whole bunch of hardware that's for a specific community that all has the same publication deadline, what do you think happens before the publication deadline? In fact, we saw that in the first year of usage, is that before OSDI deadline, you know, the hardware was incredibly highly utilized and nobody could get access to it and stuff. So this idea that we could shift hardware between them, at the end, I think we're hoping that everything is in ESI in the whole data center, and then there's no issue of sharing because you can just hand it out to CloudLab or to NERC or to OpenStack or OpenShift or to OKD or all these, or even the HPC clusters eventually. Kind of the goal is that we can move the hardware to wherever it's needed before whatever deadlines they have, because we'll have fairly large numbers across the whole stack. I mean, there's more questions for specifically CloudLab on top of ESI? I mean, this was heroic work. I did not realize how complicated this would be. I think we should all give Emmanuel a big clap for this. This was pretty impressive.
Also, I think something I would like to convey to everybody here is that some software is not necessarily that is the most popular, is not necessarily the best software. So there is always a question of timing when things are ready to use on a specific platform. But documentation and user interfaces are very important. Now, I've seen that I've been for more than 30 years in this field. Sometimes it's a software that has the best documentation, the best support, and the best interfaces that people use, and it's not necessarily the one that have the best technology underneath. And so I think that ESI is very close to taking over everything, and now I think the emphasis is really on making better documentation, maybe more user-friendly interfaces building on top, which are very easy things to do rather than re-engineering everything under something old.
So I guess we should clap for Min too.
Next is Peter. Oh, more questions? Oh, sorry, there's another question.
Sorry for the last minute running. Emmanuel, so it was fascinating, the story about all the interesting use cases or corner cases, rather, that you ran into while making ESI work with CloudLab. Can you extrapolate from that general design principles for systems that should work well with this kind of with a model where you shift resources from one system to another?
Yeah, that's a very good question. I think the way CloudLab is a lot of legacy code that was originally designed for small clusters like stuff we had 25 years ago, where we didn't have cloud. It was really just those start of those HPC clusters, and everything is still SNMP in there. It's same FreeBSD as I was doing, and I was using during my postdoc 25 years ago, and people just, it's an academic project where you had people running in every year and piling up patches on top of patches on this piece of code. It's still amazing that this thing still runs actually today.
Yeah.
I think the main issue with the CloudLab design is that a lot is still centralized in Utah. So even if I want to onboard nodes in Massachusetts, they have to update the database manually in Utah. We can't even do that. They have to add that information in the database in Utah and push that back to our local database in Massachusetts that is actually just a cache of that.
Yeah.
And it's really meant as a centralized system that is very hard to distribute or run your own instance. Where ESI, for example, if you have your own data center, it's easy to deploy and have your own set up and running independently of anything else. CloudLab cannot run without a connection to Utah. So that's, I think after that, picking whatever environment you need for managing your data center is going to depend on the skills and the knowledge that your staff has for that. And making things interconnect with other data centers or other systems, it's also a lot of human factors that are involved. Admins don't like to share passwords. They never trust each other. Interconnectivity needs also a lot of political influence at the higher level to make things happen. And it's like, yeah, no, you guys have already to work together to make those interconnects. I mean, I think ESI right now is probably the easiest and best solution to get the hardware management from all the frameworks I've seen so far. But software also evolves over the years, so it's great to have a team that can be behind and follow the evolution and not get stuck in old designs that are super hard to refactor after a while.
Yeah, well, thank you. I didn't mean to put you on a spot. It's just, it's fascinating work, and I think we could probably stretch based on your experiences, things that you encountered while making this work with CloudLab to gain insight into how design flexible systems in general. Would be a fantastic result.
So some of the problems that Emmanuel's pointing to were, they're very specific CloudLab. We actually had a couple of students doing projects to try to elastically move things, and I drunk the Kool-Aid where I believed that all these systems were intrinsically designed so a hardware node could fail or a bunch of nodes, and so we could use those mechanisms. Yeah, it wasn't so easy. You know, there's the inventory system that every one of these things have, where they assume they have a static inventory, they own it. There's then, even though they can kind of fail at a certain granularity, there's the scheduling gets all messed up when a node goes away because they don't actually have it on their normal critical path. It took a lot of design at the layers above. A student that was doing a marketplace to move things rapidly. It was, so it is going to take, I think that it's really important, the comments you make is to start expanding the principles, you know, not just the remote database and things like that, but also, and part of the work that, you know, for example, you saw today is we're trying to build an inventory system so that there's a source of truth so we can provide to everybody, and then they only know about the nodes they have right now. Right, so a lot of these mechanisms we're gradually building up as we get experience, because NERC has to acquire and release these nodes, not just stand up a new cluster on top of it for OpenShift or OpenStack. And it's going to be a while till anybody builds into their base mechanisms the concept that these actually production clusters are really themselves elastic. So it's harder than we thought it was going to be, or we knew we'd run into issues, but I don't think we expected it to be, the platforms that were deemed to be elastic and fault tolerant would be quite so hard to integrate this elastic hardware. And right now, it's okay because I think we're talking about a matter of, you know, moving nodes, you know, days, for days at a time. Eventually, we'd like to do it at a much finer granularity than that. You know, capture binaural patterns, have machines in a cluster for hours at a time, or even less. And in fact, what Peter's going to talk about is mechanisms we've been setting up for disaggregated storage to have things be able to be in there for very short periods of time in the cluster. But it will take time to propagate this up to all these higher layers. So we're building the plumbing.
One more over here.
So does the CloudLab give you geographic extent, and NERC is only right now in Western Mass, right? That's the only data center that NERC has, right? So if I wanted to do one of these edge computing research, would CloudLab be the sort of the input into the NERC big cloud?
Well, that's way above my pay grade because, I mean, the things that I've seen in CloudLab, because actually in the CloudLab interconnects between the different data centers, you can use OpenFlow and program whatever network protocols you want. So they have focused on the networking aspects for folks that were doing research in networking. I think here we're more focusing on just running workload on the machines we have. Actually, even the interconnect of the Massachusetts site to the rest of CloudLab, the uplink connection is pretty limited to do that kind of connections. I think it's not even working at the moment, if I remember correctly. So it's really meant to, most of the users we have of OCT on CloudLab are just reserving and using nodes in the MGHPCC and running their experiment within MGHPCC without trying to stitch them with other resources outside this CloudLab site of Massachusetts. So, but I think there is a connection between OCT and Fabric at the moment. So there is a connection between those nodes you can get in Massachusetts to the rest of Fabric. But between NERC and OCT, I don't know what the plans are. I don't know if Oren has a comment on that.
So eventually, we're hoping to incorporate other data centers in this kind of open cloud model. Right now, I mean, NERC things can clearly communicate with, you can get bare metal machines on OCT, and we can directly communicate through, internet with, but it's within the data center with NERC. But I don't think that was the question. It's more about the geographical distribution. And the only story now is CloudLab, yeah. And Fabric, of course.
So,
and Chameleon, of course.
And
yes,
Chameleon,
sorry.
yeah.
So do you see the ESI as like a virus that might expand out to the CloudLab to get a new generation of software on it? Because you were complaining that the old generation needed some upgrading.
I'm not sure I got the question. Could you repeat that?
So ESI is a new generation, lots of backing between it. Yep. Can you see that software being incorporated into the OSI or into the CloudLab software, because you were complaining that CloudLab was old at this point, the software was old at this point?
I don't see it being incorporated in CloudLab in the sense that it would require way too much refactoring of the software. The best we can hope is having a ESI driver pretty much in CloudLab so that we can run ESI managed resources from within CloudLab. I think that's our best hope. Sure. There are still challenges. There's going to be challenges and limitation even in that implementation, but I think that's our best hope.
So I guess I disagree. So I was talking about this with Rob a lot when we were sort of kicking off this collaboration, and I think that there's basically if you take OpenStack or OpenShift or CloudLab or all these different projects, they kind of couple the allocation of nodes, some of the network, the switch control, and the provisioning of things all together into offering an end-to-end service for all their different things. And fundamentally, the premise behind this work is that we can decouple these things, that we can actually have the allocation of the nodes and sort of the fundamental switch control decoupled from all these environments that provide very powerful services for a particular user community on top of that physical hardware, and they can do their own provisioning of the physical machines and everything else. And I think that, Rob would be very excited to do this because it sort of removes one layer of stuff from his project, and we can build that as a fundamental layer. We're not there yet, but that's where the point is that we first built the foundation here for ESI. Now we're doing our integrations into OpenStack, OpenShift, and OCT. And yeah, that is our hope, is that this becomes kind of a fundamental layer under these other things. But I wouldn't call it a virus. I'd try to be a little more positive about it. Sorry, Emmanuel, do you disagree with that, or is that?
Yeah, I kind of disagree in the sense that the CloudLab software is not a modular software. Like, ESI, you have those modules, and you have those specific pieces of code that have specific tasks, and everything is mixed in CloudLab. It's like just scripts coding each other piled up like this. So if we extract the hardware management layer that ESI is doing now, there's so much rewriting that it's like, why not use the rest of the components you already have on top of ESI, and why try to refactor and re-engineer the entire CloudLab? Is probably going to be more work than just using what you already have. So it's not like we can simply extract the Pixie boot part of everything is intertwined with the switch management and stuff, and everything is calling each other, and it's a super, I mean, it's an old software that was designed almost 25 years ago, so, and it has never been refactored, so it's not like a modern software where, yeah, you have modular pieces that you can replace and improve and change, so it's much more challenging than that. But in concept, yeah, I'd love to have, just remove the hardware layer from CloudLab, put ESI instead, but it's not going to happen like that, unfortunately, with the way the software is designed at the moment. Okay, I think we have to leave the, we are out of time and need to give the, but I'll be around for the rest of the day, so if you want to talk and stuff, we can follow the discussions over there. Thank you again.